A single star exploding can produce more energy than our sun will in its entire 10 billion year lifetime, in a single second. It can outshine an entire galaxy of 100 billion stars. It can create every atom of gold in the universe. Supernovas are the most violent, most creative, and most important events in the cosmos, and they are weirder than anything you can imagine. When a star goes supernova, it can briefly produce more light than the entire galaxy it lives in. A galaxy like our Milky Way contains about 100 billion stars. A single supernova can match or exceed the combined light output of all of them for several days. The brightest supernova ever recorded, called Assassin-15 was 570 billion times brighter than our sun. It was visible from 3.8 billion light-years away. Every atom in your body heavier than hydrogen was forged inside a star. But the heaviest elements, the iron in your blood, the calcium in your bones, the iodine in your thyroid, those were created in supernova explosions. When a star explodes, the extreme pressure and temperature forge elements that can't be made during normal stellar fusion. The carbon in your DNA, the oxygen you breathe, the nitrogen in your muscles, all of it was once at the center of a star that exploded billions of years ago. You are quite literally stardust. When a star goes supernova, 99% of its energy is released as neutrinos, not light. Neutrinos are ghostly particles that barely interact with matter. Trillions of them are passing through your body right now. But in a supernova, so many neutrinos are released that even though most pass straight through, enough interact to be lethal. If you were within about 25 light-years of a supernova, the neutrino blast would kill you before the light from the explosion even reached you. The neutrinos travel slightly faster than the shock wave that produces the visible light. The extreme conditions during a supernova explosion are intense enough to forge elements that don't exist anywhere else in the universe. The explosion creates a brief moment of nuclear chaos where atoms are smashed together at incredible speeds. This is where elements like plutonium, californium, and einsteinium come from. These elements are so radioactive that they barely exist in nature. The supernova is essentially a factory for the heaviest, rarest, most unstable elements in the periodic table, most of which decay back into lighter elements within days or years. In the year 1054, astronomers in China, Japan, and the Middle East recorded a new star in the sky that was so bright it was visible during daytime for 23 days. It was a supernova. Today, the remnant of that explosion is the Crab Nebula, a glowing cloud of gas about 10 light-years across, expanding at 1,500 kilometers per second. At the center is a neutron star spinning 30 times per second, the crushed core of the original star. The nebula is still expanding nearly 1,000 years later and will keep expanding for thousands more. If a star within about 25 light-years of Earth went supernova, the gamma-ray burst could destroy our ozone layer, letting in lethal UV radiation that would kill most life on the planet. The good news is there are no stars near us that are likely to go supernova anytime soon. The closest candidate, Betelgeuse, is about 640 light-years away, far enough to be harmless. But in the past, supernovas near Earth may have caused mass extinctions. Some scientists link a supernova 2 to 3 million years ago to a marine extinction event around that time. Because supernovas are so bright, we can see them in other galaxies millions of light-years away. And because they follow predictable brightness patterns, called light curves, we can use them as standard candles to measure cosmic distances. This is exactly how scientists discovered in 1998 that the expansion of the